Hello friends, I am Assistant Professor Milan Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today I will discuss the chapter number 2 from the renewable energy systems, and the topic is solar energy basics. So it is the basic information regarding the solar energy. Now, flow of contents. First one is solar energy, types of it, solar heating, solar cooking, solar electric, and last one is Planck's law. So now, uh, this is a great word said by Thomas Edison in 18th century that I would put my money on the sun and solar energy. What a source of power it is. I hope we don't have to wait till oil and coal run out before we tackle that. So Thomas Edison said that we have to start use of solar energy. We don't have to wait for finishing the crude oil and coal for it. So it is a great word said by the Thomas Edison. Now there are main two categories are available in solar energy. First one is solar thermal energy and second one is solar photovoltaic PV energy. This solar thermal is mechanical engineering topic and solar PV is an electrical topic. So solar thermal again categorized in two type. First one is water heating or any heating purpose, and second one is for cooking. And solar PV is used for electricity production. So now this is solar energy which is used for cooking. So this is reflecting plates which will give heat to your food for boiling or any heating purpose. And this is a heat collector which will use to heat up your particular material. Now we will see the basic diagram of solar water heating. This solar water heating is nowadays very popular due to the high charges of the gas water heaters. So it mainly consists of solar panels. These are circulating tubes or pipes in which carrier fluid is circulating. So this solar energy is directly apart on the solar panel, and due to this solar panel or heat collector, the carrier fluid in this pipe will heat up, and due to this heat and also this fluid is in circulating motion like this, and spiral arrangement is provided in this tank for more contacting area. So this carrier fluid will carry the heat and in this tank, due to this spiral arrangement, heat will exchange, and in this tank cold water will be there. So this cold water will become hot due to this carrier fluid heat. This is pump for circulating the carrier fluid, and we can use hot water from this tank, and this is a hot water outlet, and this is the cold water inlet. We can use this hot water in bathroom and any other purposes. So this is the solar water heating. Now, how does it works? So solar water heaters come in a variety of designs. Now, main parts are collector and storage tank there. So this is a collector, and this is a storage tank. Main two types of water heaters are there. First one is direct water heater, and second one is indirect water heater. Indirect water heater, the system circulate water through solar collectors where it is heated up by sun directly. When it is heated up by sun directly. And in indirect water heater, a non-freezing liquid is used to transform used to transfer heat from the sun to the storage tank water, and the sun's thermal energy heats the fluid in the solar collectors. Then this fluid passes through the heat exchanger in the storage tank. The fluid will passes through these black pipes, which are called heat exchanger, and it will transfer the heat to this storage tank water. Another two types of solar heaters are there. First one is active and second one is passive. When the system uses water pump, then it is called active solar water heaters, and if there is no water pump for circulating purpose, then it is called passive water heaters. Now, another most important application of solar energy is solar cooking. Solar cooking is done by means of sun's ultraviolet rays. A solar cooker lets the UV light rays in and then converts them to longer infrared lights rays and use them for food heat up. If it is not the sun's heat that cooks the food, also the food is not cooked by the surrounded temperature, but it is the sun rays that are converted to heat energy that will cook the food. So must clear the concept of the solar cooking, that the food will prepared by sun's UV rays, not by the sun's heat energy or the higher ambient temperature of the surroundings. Many advantages of the solar cookings are there. First one is no wood or fuels required. Then second one is no air pollution. Third one is no greenhouse effect. fourth one is eliminates the fire dangers. Now solar cooking will take 1.5 hours for vegetables to cook, 1.5 to 2 hours for rice or wheat, 2 to 3 hours for beans, 1 to 3 hours for meats, and 1 to 1.5 hours for the bread. Now solar electric or photovoltaic. Now solar electric systems. It is also called PV system, which converts light energy directly into electricity, and commonly it is known as solar cells. The simplest systems power the small calculators we use every day. More complicated systems will provide a large portion of the electricity in the near future. And PV represents one of the most promising means of maintaining our energy intensive standard of living while not contributing to global warming and pollution, because it is green energy and clean energy which is directly available from the solar radiation. Now, how does it work? The sunlight is composed of photons or bundles of radiant energy. When photons strike a PV cell, they may be reflected or absorbed or transmitted through the cell. Only the absorbed photons generate electricity. When the photons are absorbed, the energy of the photons is transferred to electrons in the atoms of the solar cell. So this is the graphical representation of the previous theory, in which the sunlight is directly apart on the solar panel or solar cell, and the solar cell is nothing but PN junction, and it will photon is strike on this PN junction, and it will free some electron from the outer periphery or outer orbit of this solar cell, and due to these free electrons or free holes, electric current or voltage will produce. Now this is a diagram for the solar cell working. A solar cell is basically a PN junction diode. PN junction diode. When light reaches the PN junction, the light photons can easily enter in the junction through P layer. Through P, so sunlight will enter in PN junction by the P layer, and due to light entering in it will create number of free electron and holes pairs, and the thermal equilibrium of this depletion layer will break, and free electron in the depletion region can quickly come to N layer. So the free electrons will come to N layer, and holes are come at P layer. So this is the depletion region, this is free electrons, and this is the holes. And now due to this depletion layer, these electrons cannot travel like this or cannot cross this depletion region, and these holes cannot cross this depletion region. So compulsory it the electron have to go from this way, and due to this the electron will flow like this from the load and due to this effect, this PN junction diode will behave like a small battery which will provide small voltage and a teeny current. So this is the basic principle and working of the solar cell or solar panel. Now solar concentrators. It will take a large area of sunlight. It will take a large area of sunlight and direct it towards a specific spot by bending the rays of the light and focusing them. It is used to improve solar efficiency of the cells or the panels. So main function of the solar concentrators are that it will collect more area of solar radiation and concentrate it on one single spot. So due to this, the efficiency of the solar cell and solar panel will improve. Now Planck's law. Planck's law is given by E is equal to hc by W, where h is equal to Planck's constant and its value is 6.626 into 10 raised to minus 34 joule into second, and c is equal to speed of light and its value is 3 into 10 raised to 8 meter per second, and W is equal to wavelength in meter. Now when the photons are incident on a conducting material, they collide with the electrons in the individual atoms. If the photons have enough energy, they knock out the electrons in the outermost cells. These electrons are then free to circulate through the material. According to Planck's law, the energy of the incident photons is inversely proportional to their wavelength. Sunlight contains an entire spectrum of radiation, but only light with a short enough wavelength will produce the photoelectric or photovoltaic effect. So it is necessary to having short wavelength of the light to produce photoelectric or photovoltaic effect. This means that a part of a solar spectrum is useful for generating electricity. It doesn't matter how bright or dim the light is. So solar spectrum is partially used for the generating electricity. Now different colors with their wavelength of lights are given here. This is the purple color having the wavelength of 390 to 455 nanometers. It is the smallest wavelength of the light spectrum, and due to its smallest wavelength, it will produce more solar voltaic effect rather than all this. And this is blue having 455 to 492 nanometers. This is green 492 to 577 nanometers. This is yellow 577 to 597 nanometers. This is mustard color for 597 to 622 nanometers, and this is red 622 to 780 nanometers, and it is the largest wavelength in the solar light spectrum. So it will produce least solar effect in solar cells or solar panel. Now previously asked GTU questions. Explain the applications of solar energy for heating and distillation with neat diagram. This is one important question from this topic, and it may be asked in 7 marks. So this is important topic. Thank you for hearing me.